Hello, everyone. In this lesson, we will study the Armature reaction of synchronous generators. Definition of Armature reaction: when a synchronous generator operates under symmetrical load. The Armature magnetomotive force, Fa, influences the excitation magnetomotive force, FF. The fundamental armature magnetomotive force of the stator windings and the fundamental excitation magnetomotive force of the rotor have the same speed, direction of rotation, and the number of pole-pairs, and are stationary relative to each other. Therefore, the combined magnetomotive force of the two will be a rotating magnetomotive force with the same direction of rotation, speed, and the number of pole-pairs. Their combination produces the air gap magnetic field in the machine. When operating without load, the stator windings are open-circuited, and the stator winding current is zero. When no load, the main flux is established solely by the rotor, and the strength of the magnetic field is determined by the magnitude of the excitation current. When operating under symmetrical load, the stator armature magnetomotive force, Fa, and the rotor excitation magnetomotive force, FF, jointly establish the main flux. The nature of the armature reaction includes direct axis demagnetizing armature reaction, direct axis magnetizing armature reaction, and quadrature axis armature reaction. The nature of the armature reaction depends on the internal power factor angle, which is the angle between the no-load electromotive force E0 and the stator current I. The magnitude of the internal power factor angle is related to the load size, nature, and the parameters of the synchronous generator. 1. Armature reaction when the internal power factor angle is 0 degrees. The armature magnetomotive force, Fa, lags behind the excitation magnetomotive force, FF, by 90 degrees. The magnitude of the combined magnetomotive force slightly increases, and it lags behind the excitation magnetomotive force, FF, by an accurate angle. At this time, the nature of the armature reaction is quadrature axis armature reaction, abbreviated as quadrature axis. The output current is the same as the no-load electromotive force. The generator outputs active power to the grid. It can also be seen from the figure that at this time the armature magnetic field interacts with the rotor excitation windings to produce electromagnetic force. Its direction is determined by the left-hand rule, producing electromagnetic torque on the rotor in the opposite direction of the rotor's rotation, acting as a braking force on the generator. causing the generator's speed and frequency to decrease. To maintain constant speed, the input mechanical power of the prime mover must be correspondingly increased. Therefore, the quadrature axis armature reaction achieves the conversion of mechanical energy to electrical energy. The generator outputs active power. 2. Armature reaction when the internal power factor angle is 90 degrees. The armature magnetomotive force, Fa, and the excitation magnetomotive force, Ff, combine in opposite directions, reducing the magnitude of the magnetomotive force. At this time, the nature of the armature reaction is direct axis demagnetizing armature reaction. The output current lags behind the no-load electromotive force by 90 degrees. The active output is zero, only emitting inductive reactive power. It can also be seen from the figure that, at this time, the armature magnetic field interacts with the rotor excitation windings to produce electromagnetic force. No electromagnetic torque is produced on the rotor due to the reduction in the combined magnetomotive force. The terminal voltage of the generator decreases. To maintain the generator's terminal voltage, the excitation current must be increased. At this time, the generator outputs reactive power. To summarize, the armature reaction when the internal power factor angle is 0 degrees is quadrature axis armature reaction, abbreviated as quadrature axis. It causes the generator's speed and frequency to decrease. To maintain constant speed, the input mechanical power of the prime mover must be correspondingly increased. Therefore, the quadrature axis armature reaction achieves the conversion of mechanical energy to electrical energy, and the generator outputs active power. The armature reaction when the internal power factor angle is 90 degrees is the armature magnetomotive force, Fa, and the excitation magnetomotive force, Ff, combine in opposite directions, reducing the magnitude of the magnetomotive force. At this time, the nature of the armature reaction is direct axis demagnetizing armature reaction. Due to the reduction in the combined magnetomotive force, the terminal voltage of the generator decreases. To maintain the generator's terminal voltage, the excitation current must be increased. At this time, the generator outputs reactive power. Generally, the generator carries both active load and inductive reactive load. Changes in active current affect the generator's speed and frequency. Changes in reactive current affect the generator's voltage. To maintain the stability of the generator's frequency and voltage, it's necessary to adjust the input power and excitation current of the generator in time with load changes. In summary, the existence of quadrature axis armature reaction is the key to achieving the conversion of mechanical energy to electrical energy. In this lesson, we learned the basic concepts of armature reaction. I hope everyone practices more after class to consolidate the knowledge after this lesson. That's all for this lesson. Thank you, everyone.